In early 1942, over the gray belt of water separating eastern England from occupied Europe, the air war entered a phase where altitude ceased to be a reliable predictor of survival. The Luftwaffe was no longer fighting an air defense system anchored only to Britain, but a widening web of intrusions, night fighters, and daylight harassment flights that exploited seams between radar coverage, fuel endurance, and pilot expectation. By February 1942, Luftwaffe 3 had standardized defensive fighter patrols along the Channel coast and the southern North Sea at cruising altitudes between 12,000 feet and 18,000 feet, optimized for early detection via Freya radar and rapid dive interception. The assumption embedded in this posture was mechanical, that any hostile aircraft operating at low altitude would be detected late, intercepted easily, and destroyed once forced to climb. That assumption would fail not because it was careless, but because it underestimated the cost of forcing an engagement across a hard vertical boundary. The aircraft that began to exploit this failure mode was the Bristol Beaufighter Mk, IF, and Mk IIF, operated by RAF Fighter Command intruder units, such as No. 252 Squadron and No. 236 Squadron, powered by twin Bristol Hercules or Rolls-Royce Merlin XX engines. The Beaufighter carried a concentrated forward armament of 4 by 20 mm Hispano Mk, 2 cannon, and 6 by .30 3 Browning machine guns, all fixed, harmonized for short-range fire. Its empty weight exceeded 16,000 pounds. Its climb rate was inferior to single-engine fighters, and its turning performance at altitude was poor. On paper, it was unsuited for fighter combat. In practice, its defining constraint was not agility, but momentum at low altitude, with dense air increasing control authority and engine output. The Beaufighter could sustain high speed close to the surface without the energy penalties imposed by climb. This made it invisible to doctrines that equated survivability with altitude. By January 1942, Beaufighter crews were flying daylight, low-level intruder missions along the Dutch and northern French coast, maintaining altitudes between 50 feet and 200 feet above sea level. At this height, German Freya radar suffered from sea clutter interference and ground reflection distortion, while Würzburg tracking radar could not establish stable solutions against fast-moving targets below the radar horizon. Visual acquisition by Luftwaffe fighters patrolling above depended on downward scanning against a high-contrast sea surface, a task complicated by glare, haze, and the narrowing of effective detection cones at speed. The technical anchor here was radar geometry. Below a certain altitude, detection probability collapsed non-linearly, not gradually, creating a blind volume that could not be patched by procedural adjustment. When German fighters did detect the intruders, interception geometry imposed an immediate constraint. A Bf-109F descending from 15,000 feet toward a target at 100 feet converted altitude into speed at a rate that rapidly exceeded the usable firing window of its 20mm MG-150-120 cannon. Closure rates compressed engagement time to seconds. Any misjudgment resulted in overshoot. Recovery at low altitude demanded either a shallow pull-out with extended horizontal separation or a violent pitch-up that bled energy and exposed the aircraft to counterfire. The Beaufighter, heavy and stable at speed, could maintain a straight-line course long enough for its rear gunner or pilot to bring concentrated forward fire to bear during the overshoot window. This was not a maneuvering fight. It was an exploitation of relative velocity and firing geometry inside a confined vertical envelope. Luftwaffe after-action reports from early 1942 repeatedly describe encounters with low-flying twin-engine aircraft that appeared suddenly, resisted interception, and disengaged before fighters could reposition. The confusion did not stem from surprise alone, but from violated expectation. German pilots were trained to think of low altitude as a disadvantaged state, one that forced the enemy into a climb or a predictable escape path. The Beaufighter did neither. It remained low, extended at high speed, and exited the engagement laterally, using the sea surface as a shield against vertical pursuit. The constraint that closed alternatives was altitude itself. German fighters could not dive indefinitely without sacrificing recovery margin, and they could not force the intruder upward without entering a pursuit regime where their advantages disappeared. Operationally, the effect was cumulative rather than dramatic. Individual encounters rarely resulted in confirmed kills. What accumulated instead was uncertainty. Fighter patrols were forced to descend to investigate low-level contacts, reducing their coverage radius and increasing fuel consumption. Others remained high, conceding the lower volume entirely. Either choice degraded the integrity of the defensive system. The Luftwaffe's strength lay in layered altitude defense. Low-level intrusions collapsed those layers into a single plane where reaction time, not climb performance, determined outcome. The technical anchor at this level was time. Every second spent descending was a second the intruder spent exiting the threat zone. Within RAF planning circles, the tactic was not described as innovative. It was treated as situational exploitation of aircraft characteristics and enemy posture. The Beaufighter's high wing loading and stability, liabilities in turning combat, became assets when operating inside a narrow altitude band where sustained speed and firepower mattered more than climb. Crews were instructed to avoid vertical maneuvering entirely, to treat altitude as a forbidden axis rather than a resource. This inversion of traditional fighter logic was what German pilots initially dismissed as impossible. Fighters were expected to climb to survive. These aircraft did not. By mid-1942, German countermeasures began to appear. Flat concentrations along the coast increased, exploiting the predictability of low-level routes. Fighter patrols adjusted their altitude brackets, and visual scanning procedures were modified. Yet each adaptation carried its own cost in fuel, coverage, or pilot workload. The low-level Beaufighter did not dominate the airspace. It destabilized it. It forced a system optimized for vertical control to expend disproportionate effort defending a zone it had previously considered irrelevant. The confusion was not tactical. It was systemic, rooted in the misalignment between doctrine and the physical limits imposed by radar, speed, and altitude. In this sense, the so-called stupid low-flight tactic was neither reckless nor clever. It was an acceptance of constraint. It acknowledged that certain aircraft could not win by climbing, and that survival lay in refusing to fight on the terms the enemy had prepared for. Early 1942 marked the point at which this refusal became visible to the Luftwaffe, not as an anomaly, but as a repeatable pattern. And once a pattern emerges under fixed conditions, systems are forced to respond, whether or not they understand why it works. The German response unfolded along predictable lines, shaped less by imagination than by available mechanisms. Coastal flak belts were reinforced with 20mm and 37mm batteries, their firing tables optimized for targets below 500 feet and crossing at high speed. This introduced a new constraint for the intruders: ballistic time of flight. At 400 km/h ground speed, a Beaufighter traversed the effective engagement zone of a light flak battery in seconds, but those seconds were governed by fixed-gun traverse rates and manual lead estimation. Accuracy depended on anticipation rather than tracking. Losses increased, but not decisively. The aircraft's mass and redundant systems allowed it to absorb damage that would have been catastrophic for lighter fighters. Survivability at low altitude became a function of structural tolerance rather than evasion. Fighter interception doctrine was adjusted next. Bf-109F patrols were ordered to stagger altitude bands, with elements detached to fly at 2,000 feet to 3,000 feet specifically to counter low-level intruders. This redistribution imposed a fuel penalty that could not be ignored. Operating at low altitude increased specific fuel consumption due to higher air density and constant throttle adjustments. Patrol endurance shortened. Coverage thinned. The defensive grid gained depth but lost persistence. The system traded time for volume, a trade it could not sustain indefinitely across the entire coastline. The technical anchor here was endurance. Every minute spent low reduced total patrol time, compressing reaction windows elsewhere. For the Beaufighter crews, the environment tightened. Low altitude offered concealment, but eliminated recovery options. Engine failure at 100 feet was fatal. Navigation errors were unrecoverable. Weather margins collapsed. Crews compensated by flying rigid profiles defined by coastline geometry, tidal patterns, and known flat concentrations. Routes were selected not for surprise alone, but for the availability of forced landing zones and friendly shipping lanes. This was not improvisation. It was constraint management. The aircraft was flown as a projectile with limited deviation, its survivability dependent on adherence to a narrow corridor where threats could be predicted, if not avoided. By late spring 1942, the Luftwaffe began to integrate early warning aircraft and improved visual reporting from coastal observers, partially restoring detection at low altitude. Yet these measures introduced delay rather than certainty. Reports arrived fragmented, often after the intruders had already passed. The defensive system regained awareness, but not control. Control required time to vector fighters, and time was precisely what low-level penetration denied. The Beaufighter's advantage did not lie in invisibility, but in transit speed through the decision loop of the defender. By the time a response was authorized, the target geometry had already changed. At the doctrinal level, the episode exposed a structural asymmetry. German air defense was optimized for protecting fixed assets against predictable attack vectors. The intruder missions did not seek decisive damage. They sought to consume attention. Every fighter scrambled against a low-level contact was a fighter not available elsewhere. Every flak battery retasked to coastal defense diluted coverage inland. The cost imposed by the Beaufighters was not measured in aircraft destroyed, but in resources diverted and assumptions invalidated. The technical anchor at this scale was allocation. Finite assets could not cover infinite threat vectors simultaneously. By the end of 1942, the specific conditions that had enabled the tactic began to erode. Allied air power expanded. New aircraft with greater range and altitude performance entered service. Radar improved. The Beaufighter itself was gradually superseded in some roles by faster, more versatile platforms. Yet the underlying lesson remained embedded in operational thinking. Low altitude was no longer dismissed as inherently inferior. It was recognized as a domain with its own rules, where advantages inverted and disadvantages became tools if treated as constants rather than obstacles. What had confused Luftwaffe fighters in early 1942 was not audacity, nor ignorance of risk. It was the refusal to compete vertically in a system designed around vertical competition. The intruders did not challenge German fighters on their strongest axis. They removed that axis from the engagement entirely. Once altitude was no longer contested, speed, time, and detection thresholds determined outcome. The air war over the sea had become less about who could climb higher, and more about who could remain inside the defender's blind intervals long enough to pass through unchanged. The pattern repeated itself until it no longer surprised. By then, it no longer needed to. The systems on both sides had adjusted, and the window that made the tactic effective narrowed until it closed. But during that window, early in 1942, a heavy, ungainly aircraft flying too low to be respected forced a mature air defense network to reveal its seams. And once those seams were seen, they could not be unseen. The closing of that window did not occur abruptly. It narrowed unevenly, shaped by improvements that addressed symptoms rather than the underlying geometry. German coastal defenses became denser, but density increased friction rather than certainty. More guns meant more firing arcs, but also more coordination delays and a higher probability of misidentification at low altitude, where silhouettes compressed and approach times were measured in seconds. Fighter patrols became more numerous, yet each additional aircraft drew from the same finite fuel pool, reducing aggregate time aloft. The defensive system grew heavier without becoming faster. Its response curve steepened, but its reaction threshold remained fixed. On the Allied side, the intruder concept matured into a defined operational role rather than an improvisation. Beaufighter units refined ingress profiles based on empirical loss data. Altitudes were standardized between 50 feet and 150 feet for sea crossings, rising only briefly to clear obstacles or identify targets. Engine settings were fixed to maximize reliability rather than peak output, accepting lower top speed in exchange for reduced failure probability. The technical anchor here was reliability. At low altitude, performance margins were irrelevant if engines failed. Crews treated mechanical endurance as the dominant constraint, subordinating all other considerations to keeping the aircraft running for the duration of the mission. This emphasis revealed another asymmetry. German single-engine fighters optimized for short, high-intensity engagements, accumulated wear rapidly when forced into repeated low-level patrols. Engines designed for altitude performance suffered from increased thermal stress in dense air. Maintenance cycles tightened. Availability dropped. The defensive network became more active but less resilient. Meanwhile, the Beaufighter's twin-engine layout, initially criticized as excessive, provided redundancy that translated directly into operational persistence. One engine could fail and still allow controlled flight. This was not a tactical advantage. It was a statistical one, expressed over dozens of sorties rather than individual combats. By late 1942, Allied planners recognized that the value of the low-level intruder was not in direct attrition, but in shaping the enemy's allocation of attention. These aircraft forced the Luftwaffe to defend everywhere at once, a task no finite system could accomplish indefinitely. The intruders did not need to win engagements. They needed only to survive long enough to impose cost. In this sense, the stupid low-flight tactic functioned as a stress test. It probed the defensive system at its most rigid boundary, where assumptions were least flexible and adaptation was slowest. At the same time, the limits of the tactic were becoming clear. As radar coverage improved and night fighter coordination tightened, the blind interval shortened. The margin that had protected low-level flight eroded as detection moved closer to the surface. The constraint that now dominated was information latency. Once warning time increased beyond a certain threshold, even by tens of seconds, interception geometry recovered. Fighters could position themselves laterally rather than vertically, reintroducing options that had previously been closed. The tactic did not fail because it was countered directly. It failed because the conditions that sustained it were gradually removed. What remained, after the window closed, was a recalibration of expectations. Both sides had been forced to confront the fact that altitude, speed, and firepower were not absolute virtues. They were variables whose value depended entirely on context. The early 1942 intruder operations demonstrated that an aircraft dismissed as too heavy, too slow, and too low could still exert disproportionate influence if flown inside a regime where the enemy's advantages could not be expressed. This was not innovation in the conventional sense. It was alignment, placing capability and constraint into temporary harmony. As the air war expanded and intensified, these lessons were absorbed unevenly, often without acknowledgement. New aircraft entered service that combined range, speed, and altitude, reducing the need for such narrow exploitation. Yet the logic endured beneath the surface. Wherever systems grew optimized around a single axis of superiority, there remained the possibility that a boundary existed where that axis collapsed. Early 1942 provided one such boundary, revealed not by experiment, but by repeated survival under conditions that doctrine had declared untenable. The story does not conclude with triumph or failure. It stabilizes. The low-level intruder became one tool among many. Its influence diluted as the air war scale increased. But for a brief period, it forced a mature defensive system to operate outside its comfort zone, exposing the cost of rigidity. That exposure, measured in fuel burned, sorties diverted, and assumptions revised, is what gave the episode its weight. Not the destruction it caused, but the constraints it made visible. By early 1943, the cumulative pressure created by sustained low-level intruder activity had shifted from tactical irritation to operational accounting. German air defense along the Channel and southern North Sea now consumed resources at a rate disproportionate to the material damage inflicted. Fighter Gruppen assigned to coastal protection logged increased sortie counts with reduced interception success, a mismatch traceable to the same constraint that had defined the problem from the beginning: detection to intercept latency. Even as Würzburg radar coverage improved and reporting chains shortened, the physical distance between detection points and fighter bases imposed a minimum response time that could not be compressed below a fixed threshold. At low altitude, the Beaufighter's transit speed allowed it to cross defended sectors faster than that threshold, turning the defensive network into a system that could observe intrusion without preventing it. This imbalance became more pronounced as Allied intruder missions diversified. Beaufighters were joined in parallel roles by Mosquito FB Mk-6 units, whose higher speed and lighter structure reduced exposure time further, but at the cost of payload and tolerance to damage. The coexistence of these platforms revealed a structural gradient. The Mosquito exploited speed to minimize contact probability. The Beaufighter exploited mass and firepower to survive contact when it occurred. Both operated inside the same altitude band, but they stressed the German system differently. The technical anchor here was decision saturation. Defenders could not optimize simultaneously against platforms that demanded mutually exclusive responses. Early engagement for the Mosquito, close-range lethality for the Beaufighter. Any posture chosen left a gap the other could exploit. German attempts to reassert control increasingly relied on preemption rather than interception. Flak belts were extended inland, and barrage patterns were adjusted to create denial zones rather than kill zones. This shifted the problem from fighter performance to ammunition expenditure and crew endurance. Sustained low-altitude alert status exhausted gun crews and increased logistical demand for ammunition resupply, particularly for 20mm systems whose high rate of fire consumed stocks rapidly. The constraint at this level was throughput. Defensive fire could be intense, but it could not be continuous everywhere. Intruders that accepted risk and maintained strict routing could still pass through intervals where coverage thinned, not because defenses were absent, but because they were finite. For the air crews flying these missions, the operational environment hardened into routine hazard rather than novelty. Low altitude ceased to be a tactic and became a condition. Aircraft were modified incrementally to survive that condition. Armor redistribution to protect engines and cockpit from ground fire. Revised maintenance schedules to account for salt corrosion and sustained high-power operation. And navigation procedures anchored to fixed coastal landmarks rather than radio aids unreliable at low height. Each modification addressed a specific failure mode. None altered the fundamental logic of the missions. The aircraft remained committed to a flight regime where escape options were limited and error tolerance approached zero. What emerges from this phase is not escalation, but normalization. The stupid low-flight tactic lost its shock value precisely because it became predictable, and predictability allowed countermeasures to accumulate. Yet predictability did not eliminate effectiveness. It merely reduced variance. Loss rates stabilized. Interception rates stabilized. The system settled into a constrained equilibrium where low-level intrusions imposed steady cost without promising decisive return. From a strategic perspective, this was sufficient. Air wars are not decided solely by moments of dominance, but by sustained pressure applied where response is expensive and imperfect. The significance of early 1942 lies in how that equilibrium was reached. It was not the product of breakthrough technology or doctrinal revelation. It was the result of an aircraft and its crews operating consistently inside a regime that doctrine had undervalued. By accepting low altitude, not as a temporary expedient, but as a fixed boundary, they forced an opposing system to reveal how much it depended on vertical separation to function efficiently. Once that dependency was exposed, it shaped decisions far beyond the intruder missions themselves, influencing how fighters were deployed, how radar coverage was prioritized, and how resources were allocated across theaters competing for attention. In the end, the confusion experienced by Luftwaffe fighters in early 1942 was not confusion of perception, but of structure. The enemy did not behave irrationally. It behaved coherently within a different set of constraints. And when two coherent systems meet under incompatible assumptions, the one slower to recognize the boundary is the one that pays the cost. That cost did not present itself as a sudden collapse, but as a steady distortion in planning assumptions. Luftwaffe staff assessments from mid-1943 increasingly treated low-altitude intrusions as a background condition rather than an anomaly, factoring them into fuel forecasts, maintenance cycles, and crew fatigue models. Fighter units assigned to coastal defense logged higher non-combat attrition from mechanical wear and training accidents, a secondary effect of prolonged low-level flying that was never the original mission profile for aircraft like the Bf-109F and G. Engines tuned for altitude performance accumulated hours in dense air, where thermal margins narrowed and oil temperatures rose faster. The technical anchor here was fatigue, not of pilots alone, but of machines operating persistently outside their optimal envelope. As Allied pressure expanded, the intruder role blurred into a broader concept of airspace denial. Low-level aircraft were no longer evaluated solely by what they destroyed, but by what they forced the enemy to protect. Coastal radar stations, flak sites, fighter strips, and logistics nodes all demanded coverage against a threat that arrived without warning and departed before a conventional response could cohere. This redistributed German defensive effort horizontally, stretching it along coastlines and transport corridors, rather than allowing it to concentrate vertically where altitude advantage could be asserted. The system's geometry flattened. What had once been a layered defense became a continuous perimeter, expensive to maintain and vulnerable to saturation. Technically, this flattening exposed another limitation. Communications latency increased as reporting chains lengthened. Low-level contacts generated fragmented data, visual sightings without altitude certainty, radar returns degraded by clutter, flak engagement reports disconnected from confirmed kills. Command decisions were made with incomplete information, often after the intruder had already exited the sector. The constraint was informational coherence. Without a stable track, interception devolved into reaction rather than control. The defensive system could respond, but it could not anticipate with the precision required to restore dominance. On the Allied side, the persistence of low-level operations influenced aircraft development priorities in subtle ways. Survivability at speed near the surface became a design consideration, shaping armor placement, control responsiveness, and redundancy. The experience fed into later concepts of ground attack and interdiction aircraft, where operating below radar horizons and inside flak envelopes became an accepted risk rather than an exception. The Beaufighter's role in early 1942 was not to define this future, but to demonstrate that it was viable under combat conditions. Viability, once proven, tends to propagate. By the time the strategic balance shifted decisively in favor of the Allies, the specific confusion that had marked the Luftwaffe's early encounters with low-flying intruders had faded. The system had learned, adapted, and absorbed the cost. But adaptation did not erase the lesson embedded in the episode. It confirmed that air combat was governed by the interaction of systems with different tolerances for constraint. Aircraft that could not compete in one dimension could still exert influence by denying the enemy the use of that dimension entirely. The monolith of the air war was built from such episodes. Not all of them were decisive. Many were incremental, their effects visible only when aggregated over time. Early 1942 stands as one of those moments where a localized choice, flying lower than doctrine advised, forced a larger system to confront the limits of its own design. It did not change the outcome of the war by itself. It changed how cost accumulated, how attention was allocated, and how inevitability was felt long before it was acknowledged. That accumulation of cost altered behavior in ways that were measurable even when outcomes were not. By late 1943, Luftwaffe coastal defense planning treated low-level intrusions as a fixed input variable rather than a contingency. Sortie schedules incorporated expected false alarms and aborted interceptions. Fuel allotments were adjusted upward for units assigned to maritime sectors, compensating for the inefficiency of patrols flown below optimal altitude. The technical anchor at this stage was predictability. Once a threat became predictable in form, but not in timing, it forced planners to budget for it continuously, draining capacity regardless of whether contact occurred. This had a downstream effect on pilot training and utilization. Fighter pilots assigned to coastal sectors accumulated flight hours that did not translate into improved combat effectiveness. Low-altitude patrols emphasized vigilance and endurance rather than tactical refinement. Engagement opportunities were rare and brief. When contact occurred, it often ended without closure. From a systems perspective, this represented negative training value. Resources were expended maintaining readiness in a regime that offered limited opportunity for decisive action. The constraint here was opportunity cost. Every hour spent defending against low-level intruders was an hour not spent refining interception skills needed elsewhere. The intruders themselves were constrained by a different calculus. Losses, though stabilized, were irreversible. Aircraft destroyed at low altitude were rarely recoverable. Crews lost at sea could not be replaced quickly. This imposed a ceiling on acceptable risk that shaped mission selection. Targets were chosen for accessibility rather than importance. Routes favored predictability over surprise if predictability reduced exposure to concentrated defenses. The aircraft were no longer probing for weakness. They were maintaining pressure within known tolerances. The technical anchor was attrition rate. Sustained operations were possible only as long as losses remained below replacement capacity. As radar technology advanced and Allied electronic countermeasures improved, the low-level regime began to intersect with new layers of complexity. Jamming reduced radar effectiveness at higher altitudes, but had limited impact near the surface where clutter already dominated. This preserved the relevance of low flight even as the electromagnetic battlefield evolved. At the same time, improved Allied navigation aids reduced the navigational penalty of operating close to the sea, narrowing one of the original risks that had made the tactic appear reckless. The constraint that shifted here was uncertainty. As uncertainty decreased for the intruder, the relative advantage of the defender eroded further. By 1944, the operational context had changed decisively. Allied air superiority reduced the need for narrow exploitation of blind zones. Fighter escorts extended deep into occupied territory. The air war's center of gravity moved inland. Low-level intrusions did not disappear, but they lost their distinctive role as system disruptors. They became one method among many, no longer sufficient on their own to force adaptation. The conditions that had made them uniquely disruptive in early 1942 were no longer present. The window had closed not through refutation, but through obsolescence. Yet the structural insight remained embedded in post-war analysis. When air forces reviewed the period, the focus often rested on technological milestones and decisive campaigns. The quieter episodes received less attention. But within staff studies and design discussions, the logic resurfaced repeatedly. That dominance in one dimension invites vulnerability in another, and that systems optimized too narrowly expose seams when confronted with threats that refuse to operate where expected. The low-level intruder of early 1942 was such a threat. It did not overturn air doctrine. It tested it. It demonstrated, under combat conditions, that altitude was not a universal solution, that speed without space created liability, and that survivability could be constructed around constraints rather than despite them. These conclusions did not announce themselves dramatically. They accumulated, embedded in planning margins and design compromises, shaping decisions long after the specific aircraft and missions had faded from prominence. The historical scale of the low-level intruder operations of early 1942 is not found in their immediate tactical outcomes, but in how they clarified the relationship between air power and limitation. These missions unfolded at a moment when air doctrine on both sides was still dominated by vertical thinking. Altitude as protection, climb as escape, energy as something to be accumulated and spent at will. The Beaufighter's persistence near the surface did not overturn that framework outright. It exposed where it failed when confronted by geography, physics, and time. In a wider chronology of the Second World War, this episode sits between phases of doctrinal certainty. The Luftwaffe entered the war with fighters optimized for short-range dominance, assuming that control of altitude would remain sufficient wherever combat occurred. The RAF entered with aircraft and command systems designed primarily for homeland defense, where radar, ground control, and recovery options reinforced each other. When combat shifted into the maritime margins between these systems, neither side possessed a clean solution. The low-level intruder exploited that mismatch, not by introducing a new principle, but by insisting that existing principles be applied inside a domain where their costs became visible. This mattered beyond the Channel and the North Sea. As the war expanded, similar constraint-driven dynamics appeared in other theaters. Over the Western Desert, altitude advantage dissolved in heat and distance, replaced by endurance and navigation reliability. In the Pacific, range and recovery eclipsed climb and ceiling as the defining variables of air combat. Over occupied Europe in 1943 and 1944, the introduction of long-range escorts and improved radar shifted the balance again, demonstrating that no configuration remained dominant once the environment changed. The low-level intruder was an early signal of this pattern. That air superiority was conditional, transient, and dependent on how closely aircraft design, doctrine, and geography aligned. From a strategic perspective, the episode underscores how air wars are shaped less by singular innovations than by sustained pressure applied at the margins of a system's tolerance. The Beaufighter did not win control of the air. It imposed cost. It forced the Luftwaffe to spend fuel, attention, and maintenance capacity defending a volume of air it could not efficiently control. That expenditure, repeated daily, contributed to a gradual erosion of flexibility. Such erosion rarely appears decisive in isolation, but it accumulates alongside other demands until options narrow and adaptation becomes reactive rather than deliberate. In historical hindsight, the ridicule attached to stupid low-flight tactics reveals more about institutional expectation than about the tactic itself. The assumption that survivability required altitude was logical within a certain envelope. What early 1942 demonstrated was that envelopes have edges, and that at those edges, logic inverts. Aircraft that refused to climb did not defy physics. They accepted it, trading one set of risks for another that the defending system was slower to price accurately. The enduring significance of the episode lies in that acceptance. It shows that effectiveness in war often emerges not from expanding capability, but from aligning with constraint, recognizing where limits are absolute, and choosing to operate within them rather than against them. Long after the Beaufighter left frontline service, this lesson remained embedded in air power thinking, resurfacing whenever new systems confronted environments that stripped away assumed advantages. Early 1942 did not change the outcome of the war, but clarified a rule that applied everywhere the war was fought. Systems fail not when they are weak, but when they are asked to operate outside the conditions they were built to dominate.